Okay, half angle identities today. It's the second to the last lesson of this unit. But before we begin, Belk had a good one, good trig. But I want to show you why Mr. Calloway does not like trigonometry or math in general. Because it's got a lot of sin in it. Sin, sine, sin. Yeah, I know. It's bad. Bad jokes. All right, half angle identity. Need to write these down. I have a new little Greek symbol for you called alpha. This is little lowercase alpha. It just means an angle. It's just like theta, okay? Or you could put like the letter A, whatever you want to put. But the sign of alpha over 2, so it's a half angle, is equal to plus or minus the square root of 1 minus cosine alpha divided by 2. By the way, this is all underneath the radical. You can look these up online if you want to. Cosine alpha over 2 equals plus or minus the square root of 1 plus cosine alpha over 2. And then tan of alpha over 2 is equal to plus or minus the square root of 1 minus cosine alpha over 1 plus cosine alpha, where this cosine alpha is not negative 1. Why is that? Because then you would have a 0 in the denominator. No. We got 2 problems for you today. Then you're going to do some homework, and like I said, we will then be done. All right, we are going to find the exact value of tan 15. Tan 15. Make sure you have your unit circle ready to go, and hopefully you will rock this out like I know you will. Okay, so the first thing I want to do is find out tan of 15 is what alpha angle could I divide by 2? And again, make that alpha be on the unit circle to get a 15. Well, I know that 30 divided by 15, 30 divided by 2 is 15. So I'm going to make my alpha 30. So I'm going to follow this right here, this formula. So this would be my alpha. So this would be plus or minus the square root of 1 minus cosine 30 over 1 plus cosine 30. Okay? Now, go ahead and go to your lovely unit circle, though you should have these memorized. The cosine at 30, the adjacent over the hypotenuse, is plus or minus 1 minus root 3 over 2. Well, this would be 1 plus root 3 over 2. And again, it's all under a square root symbol. So now we got to clean this up. I do not want to see this over a fraction. I want this to be all one fraction under a radical, simplified if possible. So let's start with that top. Actually, let me move over here. I'm going to need some space. So 1 minus square root of 3 over 2 is the same as 2 over 2 minus square root of 3 over 2. You agree to that, right? 2 over 2 is 1. This would be 2 over 2 plus square root of 3 over 2. Put my plus and minus in front. When you have fractions with like denominators, you can just combine the top. So this would be 2 minus root 3 over 2. The bottom would be 2 plus root 3 over 2. And it's all under a square root with a plus or minus in front. All right, now this still looks terribly complicated. Well, remember, when you divide two fractions, you do same change flip, multiply by the reciprocal. So this is really the square root of 2 minus root 3 over 2, that's the top, times the flip of the bottom. I flip the bottom. And notice what happens. These cancel. I'm left with the square root of 2 minus root 3 over 2 plus root 3. And again, still looks nasty. Tan is usually nasty, but how can I clean this up and get this radical out from under there? Well, you can multiply by the conjugate, okay? So I'm going to multiply, it's hard to see, I'm going to squeeze it in here, conjugate of the bottom, 2 minus root 3, 2 minus root 3, okay? And what that does for me is, I'm going to start on the bottom because I know what happens. Remember, you don't FOIL, you can just fluh. The middles will drop away. So you get 4 minus square root of 3 times square root of 3 is just 3. The top, don't FOIL it out. Actually write it like this. 2 minus root 3 squared, because you're multiplying a 2 minus root 3 times another 2 minus root 3. Trust me on this. There's a reason to that. And remember, still under a radical with a plus or minus in front. Okay, almost done. What happens when you square a square root? When you square root and squared, what happens there? Oh, they cancel. So really, and then what's 4 minus 3? 1. So really, you just have 2 minus root 3. But you have this little plus or minus in front. So here's what you do with the plus or minus. Where is tan of 15 located? Quadrant 1, quadrant 2, quadrant 3? It's in quadrant 1, right? Is tangent positive in quadrant 1? Yeah, everything's positive in quadrant 1. So see this little plus or minus in there? It's really just plus. That's how you figure out that last step. You could actually have done that in the beginning, but that's how you figure out if it's going to be positive or negative. Okay, depending on what quadrant the original is from. So your final answer in exact form is 2 minus root 3. Done, done, done. All right, I'm going to do one more for you. And these are the harder ones, so the ones that are easier, you will like better. Sine of negative pi over 8. So negative pi over 8, I'm going to just help you out with that one. That is the same as negative 22.5. I converted it. If you don't remember how to convert from degrees to radians, you should. But that's the sine of negative 22.5. So if I think to myself, what is that? What divided by 2 would make that? Well, let's just multiply by 2. That would be 45, negative 45. So this is really the sine of negative 45 in degrees over 2. I just like this better in degrees. Sorry. Okay? It just makes it easier for me. So what does that mean? Well, this would be the sine of negative 45 over 2. This would be my alpha. So then follow the formula. Again, what's the formula for sine? Plus or minus square root of 1 minus cosine alpha over 2. Okay, so plus or minus square root of 1 minus cosine at negative 45 divided by 2. The cosine at negative 45 is the same as the cosine at 315. Cosine at 315. So go to your unit circle and let's find out what the cosine at 315 is. It is root 2 over 2, and it's positive, but this right here is negative. So 1 minus root 2 over 2, all divided by 2. And this is all underneath, by the way. All right, and again, clean up this fraction. 1 is the same as 2 over 2 minus root 2 over 2, all over 2. Put your lovely fractions together, you would get plus or minus the square root of 2 minus root 2 over 2 over 2. Same, change, flip. So I hope you figured it out, but what does that mean? This would be then plus or minus the square root of 2 minus root 2 over 4. And then we're just going to clean this up. And we're going to rewrite this as, it's going to be weird. You're actually going to separate the radical. You're going to go square root of 2 minus root 2 on the top divided by the square root of 4 on the bottom. And the square root of 4 is 2. So the whole top has a square root, just a square root on top, but the bottom just has a 2. That looks so crazy, but that is considered exact form. The square root of 2 minus the square root of 2 all over 2. That is the sign of negative pi over 8. Oh, wait, is plus or minus? Where is negative pi over 8 located? Well, that would be in quadrant 4, right here. And all students take calculus, not cocaine. And that would be then only cosine is positive. We're doing a sine, so this would actually be negative. Okay? All right. So there's just 2 examples. That's it. Your homework tonight, this page right here, it says 14.6, practice, double angle. You're doing 1 and 3. Now this goes back to, you're going to find the sine of 2 theta, the cosine of 2 theta, so those are double angles. Then you're going to find the sine of theta over 2, and cosine of theta over 2. You're going to find the half angles. And then you're going to do 5, 6, 7, and 8. 5, 6, 7, and 8. And actually, I know, you're welcome. So you really have 4 problems. That's embarrassing. It's okay. All right. Good luck. Have fun. Bye-bye.